Time dilation. Einstein's theory is important to everyday life because GPS wouldn't work properly without it, since due to time dilation, the time for satellites is different to the time on Earth, and the knowledge of time dilation allows engineers to account for that inaccuracy in their calculations. The basic principle of relativity. If you had two cars moving at 60 and 40 miles per hour respectively, you would say that that's their speed relative to the Earth. But if you were to say what their speed relative to each other was, you would say 20 and 0 miles per hour respectively, because comparatively, the blue car is travelling at 20 miles per hour faster than the red car. Einstein's theory of special relativity is that time runs differently for people moving relative to each other, and the mass of an object increases with speed. In order for his theory to work, he assumed that in all inertial frames, physical laws have the same form, and in free space, the speed of light never changes. An inertial frame is where Newton's first law is obeyed. Newton's first law is an object won't accelerate unless an external force is acting on it. Time dilation was proved in the 1970s when 4 atomic clocks were flown around the world twice, and were then compared to reference clocks in the US. When compared, they found that the clocks from the planes were actually slower than the reference clocks. To work out the exact amount of time dilation, you use this equation, where T0 equals the time for the stationary observer, T equals the time for the object moving, V equals the velocity of the moving object, and C equals the speed of light. The last thing to remember is, when using the equation in practice, remember to check you got your T's the right way around.